Do you know what a Pythagorean triple is? Interesting. Who does?
I do.
Yeah?
It's well, I read this page, but it's like the triples of it's like the triples of like the 3, 4, 5 that can make a Pythagorean theorem triangle, and then you just double it, triple it, quadruple it to make another diamond.
Wait, you read the page?
I read the page.
He read the page. So you want to add in that they're whole numbers. So 3 whole numbers that satisfy the Pythagorean theorem. So the most common one that we see is the 3, 4, 5 right triangle, because 3 squared plus 4 squared equals 5 squared. So 3, 4, 5 is a Pythagorean triple. Okay. Now, let's remember the Pythagorean theorem. What do we call C? The hypotenuse. And what do we call A and B? They are both legs. Okay? It doesn't matter which one's A, which one's B. They're both legs. Addition is a commutative property. Okay? Commutative means you could, like, 2 plus 3 is the same as 3 plus 2. Okay? Now, question for you. How do we know which one's the hypotenuse? What do we look for? It's always opposite of the right angle. Okay. Excellent. Now, could you please draw this picture where it says notes? Right there. Thank you. Okay. Something that's going to be a little different now is that when we use the Pythagorean theorem, you will not be giving me a decimal approximation. You will be giving me an exact answer. And by exact answer, I mean a reduced radical. Which one's the hypotenuse?
14.
So 7 squared plus x squared is 14 squared.
49 plus x squared equals...
Okay. What is 14 squared?
150.
196.
I like that. That's an awesome number. What? You said that awesome. Oh, I did. I said a 100 or something. I was hating.
X squared equals 147. Okay. Interesting. So right now we have square root of 147. Act like you've lived in Nebraska before. Sorry, Derek. Okay. Is 147 a number that we can reduce?
Maybe.
So we know it's not even. I look at 147 and I'm like, I don't know. Do you know the trick for seeing if a number is divisible by 3?
Divided by 3.
Hey, can you just listen to me? If you add up the digits and that number is divisible by 3, the whole number is divisible by 3. Oh, so it's divisible by 3. 3 times what?
49.
12.
Well, that is interesting.
Well, we just did something times 49.
Okay, that's cool. Okay. A second picture I want you to draw. Man, I'm terrible at that. Okay. I would like you to take a moment and solve for the hypotenuse of this right triangle.
Okay. Well, let's see you do it. 6 squared plus 4 squared is 16.
52.
52 squared.
Right equal 52. Well, I got right equal 52. I'm not that sweet.
So that's 28.
Divided by 3.
I was thinking in my head.
Okay, 4
I got 2
Divided
squared
by
root
4.
2 square root. 2 divided by 4 is
Yeah, that's what it is. 4 times 13. 4 times 13.
So 2 times the square root of those.
Okay, so I'm here arguments, but the argument of 2 radical 13 is winning.
Yep.
So we're taking 4 squared plus 6 squared, which is getting us
16 and 36.
52. And since 52 is 4 times 13, our answer is 2 radical 13, excuse me. Okay? Now, if we have a Pythagorean triple, that means the 3 numbers satisfy the Pythagorean theorem. Okay? So here are like the most common ones we're going to see, 3, 4, 5, and any multiple of that. So like 6, 8, 10, 9, 12, 15. See how those are just like times 2, times 3 of those. 5, 12, 13, 8, 15, 17, 7, 24, 25. The more you get into your math career, the more familiar you're going to be with these triples and be like, oh yeah.
Yeah, I get that one.
Like if I give you a triangle with legs, if I give you a right triangle with legs 5 and 12, the hypotenuse is going to be 13.
How do you know? Because I never said. Oh, it says that on the sorry.
Okay. But if we take 5 squared plus 12 squared, it's going to equal 13 squared. 25 plus 144 equals 169. It satisfies the Pythagorean theorem. Okay? Now, what if it doesn't satisfy the Pythagorean theorem? Okay? Basically, if we are given 3 numbers that represent the sides of a triangle, if it satisfies the Pythagorean theorem, it will be a right triangle. If it doesn't satisfy the Pythagorean theorem, it's not going to be a right triangle. So if we go to this next page, which you don't have to even flip a page, look at that, okay? If I give you, hey, I have this triangle, and I'm not sure if it's a right triangle or not, but I know that the sides are 8, 7, and radical 113, okay? How do we know which one to make our C value?
The one with the right. The biggest one.
The biggest one. We don't know if it's a right triangle, so we don't know which angle's the right angle. So we're going to pick the largest one. In this case, what's the largest?
113. Square root of 113.
Square root of 113 is going to be slightly bigger than 10, almost 11. How do I know that?
Because
Stop giving answers like that.
10 squared is 100 and 11 squared is 121.
Ah, yes. So 113 is in between 100 and 121. So I know its square root is going to be between 10 and 11. Okay, so is 8 squared plus 7 squared equal to 113 squared? Question mark.
Yes.
Okay, so you're telling me that 64 plus 49, what's the square root of 113 squared?
What do you do? Wait.
113 is 113 times 113 or square root. Yep.
You could just do this. Okay.
So that's great.
Okay.
This is a retro.
Now, we could say, all right, well, if it didn't equal, it's not a right triangle. But we can be more specific. If you do the a squared plus b squared and c squared, if a squared plus b squared is bigger than c squared, then we have an acute triangle. If c squared is larger than a squared plus b squared, then we have an obtuse. So just because it's not a right triangle doesn't mean we don't know anything about it. We can tell with the converse of the Pythagorean theorem whether it's acute or obtuse. So I'm going to give you three triangles. One has sides of 10, 24, 26. One has sides of 5, 8, and 10. And one has sides of 14, 10, and 15. Could you please use the Pythagorean theorem to determine if we have right, acute, or obtuse triangles? Ready, set, go. Work with your table.
Right angle.
The first one is.
No, the 10 squared. How do we figure this? Oh yeah, that was good. That was good, Ollie. Wait, say it now.
No, you're like, wait, Ollie. That's actually good.
Wait. That's actually good. Wait. I knew this. I knew this.
Okay. I can't even count how many times you said that, Alex.
Do I have to like memorize
Every social studies, all he said is like, oh, I knew this was happening.
You say it all day yesterday.
No,
So it's,
it's not free.
obtuse.
So
Wait, what's
you
the
gotta
first
figure out if
What's the
if
first
c
one?
squared is bigger or smaller than a squared.
Right? Oh, the first one, right?
Well, yes, 100 is not going to be
You
bigger
get right for the
than
first
5
one.
or 2. Yeah.
Wait a minute.
Oh.
Wait, yes, it is. Oh, really?
Yes.
Wait, guys, this.
Yes, no. Wait, Ollie. You're supposed to figure out.
Nobody laughs.
It was funny when you did it the first time.
Yeah, it's kind of so stupid.
A remake of I Knew This Was Happening.
I didn't expect it.
Wait, guys.
Oh, that was good, Ollie.
Yeah, that's how the second one's. Yeah.
Is the next one obtuse?
The second one is not.
It's not obtuse?
I don't think so. Because
I looked over it.
25.
5 squared plus 8 squared equals 25 plus 64. That's less than 100, so it's
Wait, yeah.
Wait, so it's number
obtuse.
45.
Got it.
Josh is right. Well, then you won't have
Okay, my lovely geometry children. As I sit by the rainy window. Okay. Aaron Letty. Hello, Miss Nixon. Aaron Letty, is this first one a right triangle? Yeah. If we take 100 plus, what's 24 squared?
I didn't do it.
Oh wait, 576.
Did Aaron tell you his joke today?
No, not yet. So is this 676?
Yes.
Okay, so it's a right triangle.
No,
Oh,
at the window for
okay.
my delivery of-
Gotcha. All right, Natalie. Excuse me, I had something in my throat. Natalie, what kind of triangle is the second one?
It's obtuse.
if we take 25 plus 64, how does that compare to 100? Oh, so this is an obtuse.
Oh my gosh.
So if it is less than,
If c squared is bigger, it's obtuse.
yes, okay,
Yeah.
that makes
Yeah.
sense.
All right, Miss Nixon is getting it. All right.
It's smaller than it's acute.
Yeah. Alex S. What kind of triangle is the third one? Ah, so cute. So 196 plus 100 compared to 225 is definitely bigger. Since c squared is smaller, we have an acute triangle. Okay. Here is the deal.